As Starship Flight 7 approaches, SpaceX is ramping up preparations with increasing intensity. Beyond recent static fire tests, Elon Musk company is set to unveil the next leap in spacecraft thermal protection technology with the introduction of Starship's new metal shield. All will be revealed in today's episode of Alpha Tech, and thanks for joining us. Before diving into the advancements in thermal protection systems, let's take a closer look at SpaceX's latest test of Starship V2. Starship V2, bearing the designation S-33, with its slightly bulkier design, fired its Raptor 2 engines for approximately 8 seconds during a static fire test on December 16th. This test came just 3 days after SpaceX transported the upper stage Starship to the Massey testing site, and 5 days after conducting a static fire of the 232-foot-tall Super Heavy booster at the launch pad. Previously, static fires for Starship's second stage were conducted at a launch pad near the main site before the Massey facility was completed earlier this year. Based on footage shared by SpaceX on their account, the static fire appears to have been successful. This is likely one of the final tests before the launch of Starship V2, making the likelihood of Starship Flight 7 happening in January very high. Unlike Flight 6, which occurred just a month after Flight 5 and benefited from FAA approval under the same launch license, Flight 7 will require a new launch license due to significant upgrades to the second stage. These upgrades include larger propellant tanks, redesigned forward flaps, and improved heat shields. The December 16th static fire test followed earlier propellant loading tests, and SpaceX may also test additional hardware designed to catch the rocket using the launch tower. If the upper stage lands gently and successfully, Flight 7 could see SpaceX attempt to catch it using the tower for the first time. Now let's move on to the highly anticipated upgrades to Starship V2, particularly its unexpectedly enhanced heat shield. During rigorous stress testing of the Block 2 heat shield, SpaceX engineers encountered a major hurdle when sensors detected a critical flaw that could jeopardize the entire Starship program. The anomaly emerged under high thermal loads just weeks before the final assembly, putting the team into crisis mode. Recognizing the urgency, SpaceX engineers quickly mobilized, leveraging their technical expertise and collaborative spirit to address the problem head-on. Working tirelessly for 72 hours, they scrutinized every aspect of the heat shield's design, examining each component to pinpoint the root cause of the flaw. Not only did the team resolve the issue, but they also seized the opportunity to overhaul the entire thermal protection system, TPS. They incorporated advanced materials and cutting-edge designs, marking a significant departure from traditional methods. And can you guess what this might be? Yes, it's likely metallic heat shield tiles. Traditionally, ceramic heat shield tiles have been the backbone of TPS designs. While effective, they come with limitations. Ceramic tiles are fragile, expensive to manufacture, and require significant maintenance after every mission. In contrast, SpaceX's new metallic heat shields offer a durable, cost-effective, and low-maintenance alternative, representing a revolutionary advancement for reusable spacecraft like Starship. At this point, some might worry about the extreme temperatures generated during re-entry through Earth's atmosphere melting these tiles. Rest assured, SpaceX has addressed this concern with innovative cooling systems that sound like science fiction but are grounded in engineering reality. These include liquid film cooling systems that dissipate heat across the surface and gas barriers that create protective layers around the spacecraft during re-entry. Such innovations are specifically designed to withstand extreme thermal dynamics, significantly improving the spacecraft's resilience. Additionally, another cooling phenomenon was identified during post-flight analysis of Starship's Flight 6. Under the intense heat of re-entry, certain sections of the stainless steel hull developed microscopic crystal structures. These formations, born from the interaction of high temperatures and material properties, enhance the heat resistance of the spacecraft's hull. This unexpected discovery has opened new avenues for research in material science, with implications extending far beyond Starship's design. Before SpaceX entered the innovation phase, the company acquired foundational knowledge about heat shields from NASA's shuttle program. One of the most striking similarities between Starship's heat shield and NASA's advanced environmental barrier material, which was used on the shuttle, lies in its construction. AETB featured a two-frock coating and incorporated molybdenum disilicide for enhanced durability during the shuttle's final years. Examining Starship's tiles suggests a complex mix, potentially including silica, aluminum borosilicate, and aluminum oxide fibers, materials reminiscent of AETB. Elon Musk confirmed that these tiles are made from silicon and aluminum oxide. Structurally, the shuttle's heat shield tiles were coated in tetrasilicide and borosilicate glass on the outer surface. Starship's heat shield tiles share a distinct black color, and during re-entry, a blue plasma glow surrounds the spacecraft, indicating the possible use of a borosilicate coating. This material is known for its low thermal expansion coefficient and resistance to cracking under rapid temperature changes. However, Elon pointed out that the shuttle's heat shield tiles were not truly reusable in a practical sense. Refurbishing the shuttle required over 6 months and involved a large team. This was due to the shuttle's complex design, where each of its 24,000 tiles was uniquely shaped and sized for specific areas, creating significant logistical challenges in production, quality control, and maintenance. Maintaining the TPS, thermal protection system, for the orbiter required up to 80,000 labor hours per mission, including quality assurance inspections, repairs, re-waterproofing, and recertification for flight. In stark contrast, Starship's TPS aims for an ambitious turnaround time of just 1 hour with minimal labor. This is achieved through nearly uniform tile sizes across the spacecraft. Only about 100 tiles have unique shapes, such as those for the nose and corners. Although this design slightly increases the spacecraft's overall weight, it provides significant benefits in terms of production, maintenance, and repair. This uniformity allows for automated manufacturing, streamlined quality control processes, reduced costs, and enhanced reliability. The design also offers a strategic advantage for Mars exploration missions, as crew members can carry spare tiles and quickly replace any damaged ones. This repair capability ensures the spacecraft's structural integrity for the return journey to Earth, greatly enhancing mission safety and success. Starting with Flight 5, SpaceX has focused on upgrading the quality of Starship's heat tiles. The company developed a new heat shield that is twice as strong or at least half as likely to crack or come off. They also introduced an ablative layer beneath the primary tiles as an additional safeguard. These secondary tiles are made from silicon and felt, designed to self-cool by slowly disintegrating to expel heat. Some specifics about the ablative material SpaceX plans to use have not been disclosed, but Elon stated that it is not intended for reuse. Instead, these tiles are designed to protect the ship and its inhabitants in case the primary tiles fall off during or before re-entry. By Flight 6, SpaceX continued to push the boundaries with new secondary thermal protection materials, signaling an ongoing evolution in Starship's development. Looking ahead, Elon Musk has ambitious plans to establish an entirely new supply chain for heat shield tiles, one that achieves low cost, high volume, and high reliability manufacturing. This vision reflects SpaceX's commitment to pushing the boundaries of space exploration technology and ensuring Starship becomes a fully reusable vehicle capable of safely transporting astronauts to and from destinations like Mars. Elon recently stated that humanity could land on Mars within 4 years and establish a self-sustaining city there within 20. While many might dismiss Elon's latest claim as another example of grandstanding, some analysts see a deeper purpose. Experts suggest that Elon's tweets spark meaningful discussions about SpaceX's immediate ambitions and the long-term prospects for humanity as a multiplanetary species. If I were diagnosing why now is the very aggressive timeline for Mars, it's partly to show that SpaceX isn't slowing down. It's not resting on its laurels, it's not turning into some kind of creaky dominant player in space, and it's still the innovative, envelope-pushing startup that it is, said Mike Wine-Zero, a professor at Harvard Business School specializing in the economics of space. Whether it's Elon Musk, Gwynne Shotwell, SpaceX's CEO, or the incredibly deep bench of talent they have, I think of SpaceX as being good at two things among many. One is turning market forces into achievements that were previously thought unachievable. The other is turning these unachievable visions into market success. That's the core of what the Mars thing is all about for them, attracting talent, passion, capital, and hard work from people outside SpaceX. The Mars mission has always been central to what they talk about and why they exist at a broader level. When you're trying to create a company that's going to change the unprecedented scale of what we do in space and rethink the future of humanity, having a vision of this scale makes so much more possible. Zero noted that revenue from Elon's other commercial space operations, most notably the Starlink satellite network and its militarized sister network, Starship, is central to funding these objectives. However, similar to the recyclable Falcon rockets and Dragon capsules that have made low-cost crewed missions to the ISS routine, SpaceX's model of reusability can work for Mars too. It's hard to know precisely how SpaceX is calculating the cost for these things because they're private. But when they talk about the cost of flying Starship, the numbers are low, into the tens of millions. Even $10 million per flight, when all's said and done, makes it easy to see how they think this is something they can fund independently, with revenues from these business lines, extra investor funding, and potentially more public funding, Zero explained. Still, settling 1 million people on Mars is an entirely different challenge. Starship has only flown 4 test flights so far, with the first 2 ending in fiery explosions. Moreover, an as-yet undeveloped tanker spacecraft will be necessary to refuel Starship in orbit, so it can carry its 100-ton payload or crews of 100 people for the 6-month journey to Mars. You're talking about a significant amount of time and development, said Robert Zubrin, president of the Mars Society. While it's not impossible to achieve within 2 years, it's a bit of a stretch. 2028 is fully possible, but you don't want to send people on a one-way trip until there are greenhouses, settlements, and a place to live. This is one of the problems I have with Elon's claim. It's not my sense that they're actually developing the required surface systems for human operations on Mars. They're working very hard on the transport system, but not yet on the systems to produce methane and oxygen on Mars at a large scale. Zubrin further pointed out that Elon seems to be stretched thin with his numerous ventures. However, he shares the belief that SpaceX will ultimately deliver much of Elon's vision, just not on the proposed timeline. Starship is going to become operational, and it's far enough along to say that with confidence. Elon frequently exaggerates both what he's going to do and how quickly he'll do it, but he still accomplishes a great deal. In addition to drastically cutting the cost of space launches and proving the utility of reusability, SpaceX's growth as a company has led some to believe it is no longer entirely dependent on Elon Musk. Zero elaborated, SpaceX has reached a point where, if Musk were no longer directing operations, it might not matter. They have an incredible ability to attract talent, and that speaks to a culture they've clearly built and maintained. This culture might owe a lot to Musk initially, but it has now been embedded in so many people at SpaceX that it's not dependent on him as much as we might think. We wouldn't want it to rely on one person, and my sense is that it doesn't. And that's it for today's episode. Thanks for joining us, and we'll see you next time.